Hello everyone, I am Ashutosh, and in this video I am going to explain histogram, which I believe is extremely important and essential for all the domains of photography. But before jumping into the content, first I would love to explain few other parameters like luminosity, brightness, and the difference between luminosity and brightness, because these ideas are also very important to understand the overall concept of photography along with histogram. So let's start with the first one, luminosity. In a very simple sense, luminosity is the total amount of light emitted by a source from its surface. The total amount of light, this section is very important. The total amount of light emitted by a source from its surface, and this is an intrinsic property, which means it cannot be dominated properly. This is something like inherent. On the other hand, brightness is only that amount of light which is finally reaching the sensor of the camera or the eye, or in a very simple sense, how bright an object is appearing to the detector's eye or the camera sensor. So luminosity was the total amount of light, and brightness is only that amount of light which is finally approaching or reaching the sensor of the camera or the eye. Okay, the unit of luminosity is joules per second. Joule is the unit of energy and second is the unit of time. So joules per second, it simply means energy per unit time, and this is also called watt. You must have seen in some light bulbs, LED, CFL or halogen light, it says 10 watt, 20 watt, 500 watt, 1000 watt. What does that watt mean? It means for a 100 watt light, that particular light has the ability to emit 100 joules of energy in 1 second. This is 100 watt. Now let's take for example, you are photographing Milky Way with a camera setting aperture 4.0, ISO 2500 and shutter speed 15 seconds, having white balance and all other parameters constant. Okay, so what does that mean? You are allowing light to enter your camera sensor for 15 seconds. And let's take for example, what was luminosity? It was the energy per unit time, and light is a form of energy. Also it has dual nature, both particle and wave, let's forget that. So light is a form of energy. So in case of photographing a Milky Way, it means you are allowing light in the form of energy to enter the camera sensor for 15 particular seconds. So this is the concept. The total amount of light emitted by the object or the Milky Way is constant. You cannot control that amount of light. You cannot say Milky Way, please reduce your intensity of light. But what you are doing is, you are only controlling the amount of light entering the sensor of your camera. How are you controlling it? You are controlling the opening or the aperture, you are controlling the sensitivity of the photograph like ISO, and the most important is shutter speed, which is 15 seconds. So it means you are allowing a particular or constant amount of energy in terms of light to enter your camera sensor for 15 seconds. So this was the joules per second, energy per unit time. And this is how a photograph is generated. I mean the image is generated in the sensor. The basic difference between luminosity and brightness is depending on the distance between the luminous object and the camera sensor or the sensor of your eye. And one important information before stepping into histogram is about pixel. Pixel is a very little amount of area. If your camera is of 24 megapixel, it means the particular sensor, I mean the rectangular sensor of your camera is composed of 24 megapixel areas. Just imagine how small a pixel is, because a typical Nikon DX format camera has a sensor with dimension 23.5 into 15.6 millimeter square, if I am not wrong, and the diagonal is about 28 point something, like 28.21 probably. So just imagine how small that particular sensor area is. Still there are 24 megapixels, so that is very intricate as well as interesting. So now we have the cutoff knowledge about pixel, luminosity and brightness. So we are ready to jump into histogram. First I shall tell what, then I'll explain why. What is a histogram, and then why we need to understand the concept of histogram to produce a better photograph. Histogram is a graphical representation of two parameters, pixel count and brightness. This is the positive X and positive Y region. Brightness is plotted in the X direction, that is the horizontal line, and pixel count is plotted in the Y direction, that is the vertical line. The x-axis shows the category of brightness values and the y-axis shows the number of pixels at a given brightness value. Each pixel in a digital image is given a brightness or luminance value ranging from 0 to 255. An image histogram results when the computer scans through each pixel of the image and counts how many pixels are there at each brightness level from 0 to 255. Brightness value 0 means there is no presence of light, it's completely dark. Just for example, our eyes cannot see anything in the dark. Similarly, that photographic instrument cannot also capture any details in the dark when there is no light. Also, when it reaches the maximum value, it means there is excess amount of light. Our eyes cannot see anything when there is excess amount of light. Similarly, the photographic instrument is also not capable enough to record any details when there is uncontrollable amount of light. And any value in between black and white, that means any brightness value greater than 0 and less than 255 falls under the category gray. For each brightness level, there is a vertical white line that represents how many pixels in the image have the corresponding brightness level. To make the display fit in the available space, the pixel counts are scaled so that the tallest line runs all the way from the bottom to the top of the graph. Now let's talk about the darkest shadow and the lightest highlight to get the idea of dynamic range. Where the histogram drops to 0 on the left, there are no pixels in the image darker than this. Similarly, where the histogram falls to 0 on the right, there are no brighter pixels in the image. These 2 points define the dynamic range of the image, the range between its darkest and lightest part. The greater the dynamic range of an image, the more contrast it exhibits. If all the lines in the histogram fall in a narrow range, this means that the histogram has only a small variation of gray levels and will consequently have a very low contrast. Whether this is good or bad depends on the effect we want to achieve. And this is the dynamic range of the camera. Okay, let's go to Adobe Lightroom and let's see which image we can take for example. Okay, let's start with the first one, the Milky Way. But oh my god, just look at the histogram. Till now we have studied only the gray histogram, but in this photograph it shows red, green, blue, yellow, magenta, I mean all the colors. So let's go to saturation and desaturate it all the way to -100. So now we have simple light plotted throughout and the histogram is gray. So let's understand the difference between simple white light and the different colors of light. This is the visible light spectrum. Actually there is nothing like white light. Lord Newton showed us that when simple light from a source is passing through the prism, it is simply getting divided into VIBGYOR. So that's the reason. So in a general sense we can assume that white light is the summation of all the wavelengths of light. Just like this. Look, what is it saying? The visible light spectrum is the section of the electromagnetic radiation spectrum that is visible to human eye, and this is also same for the camera sensor. I mean the range is same, which is varying from 400 to 700. Okay, so we are back to the Lightroom and let's investigate how the histogram is directly related to this photograph. These bright areas represent this portion of the histogram and these dark areas represent this portion of the histogram. And in this photo most of the areas are in midtones, so that's the reason there is a spike on this in the histogram. Let's get our saturation back, and this is the logic. When we are simply dividing the white light into different colors, we are getting the red, green, blue and all that. Similarly, in this histogram, these areas represent this highlight portion and the dark areas represent this portion, and the rest of the areas are varying from less dark to mid-tones. So basically, histogram tells us about the exposure of the image, either properly exposed or not, overexposed or underexposed. And install one important idea in your mind, that there is nothing like a perfect histogram. The only thing histogram does is it tells us about how much light is there. Now let's take for example, if your histogram is looking like this, okay, it is climbing on the right side wall, it means a huge amount of area of the photograph is completely blown out, overexposed and purely white, having no details. Similarly, if it goes back to 0, if I reduce the black to -100, it means these areas are completely dark and have no details. So as a photographer, you have to keep in mind that when you are taking a photo or you are editing a photograph, no area should be completely blown out and no area should be completely dark. I mean details less white or details less dark. So this was all about the basic concepts of histogram. Actually there are so many things to talk about, but I think for a photography enthusiast or a photographer, this information is enough, but you can always learn more. Thank you.